And good morning, everybody. We're going to talk about C#9 today. Now, a lot of the features in C#9 have been in development for quite a while. Records in particular has been in development for almost a decade. So you may have seen code similar to this in my previous talks with slightly different implementations or slightly different approaches. C#9 shipped last November, so everything in this talk you're going to see today is now final and available for you to use. So I'm calling this the definitive edition. Everything is locked down. This is C#9. And I'm Scott. I currently work at Xandr. We are an advertising company, but we're not Google, so you may have not heard of us before. And I'm an engineering manager at Xandr, and I also work for prebid.org, which is an open source community of projects rather, to focus on technology for the advertising industry. Specifically, I'm the lead designer for Prebid Server, which is written in Go. And if for some reason any of this interests you, we are always welcoming to new contributors. So I like to usually begin these sort of talks about C# with some history about the language and about where we are today. But C# over the last 5 years has really exploded in growth. And even just trying to go through a quick, just hit the highlights of C# now has become really not really feasible. So we're going to go through, just to start off, give you a little bit of history and massively abridged history of C#. So version 1 shipped in 2002, and that's the initial release. It was quickly followed on with other versions that included generics and async functionality. But over time, it became a lot harder to add new features to C#. The original compiler that they wrote just was fighting against them. There was also a compiler, for C# was also separate from the language services of Visual Studio. So it made it very difficult to try to add new features. You had to do it in at least 2 places, in reality, a few places more. The tooling chain just wasn't up for the task. So C#6 in 2015, they rewrote the entire C# compiler in C#, and that's called Project Roslyn. Now, this was released in 2015, but it was a very long development effort. And when they finally released it with C#6, came along a lot of community requested features. Some were really small, some were massive. But they were all things they wanted to do for a while, just couldn't because of how hard it was to implement. Now, ever since then, C# language has been exploding. There's been tons of new features in every new version, really major things that make your programs a lot simpler and a lot easier to express. Roslyn is part of the .NET Foundation, which is I think it's a nonprofit organization that monitors and controls, watches over all open source projects involving .NET. And Roslyn was one of the very first projects as part of this. Now, C# is entirely open source, and the compiler called Roslyn is found at GitHub under .NET Roslyn. And you can go here to view the source code for the C# compiler, and it also serves as a Visual Basic compiler. There's a second repo too, and this one might be more interesting to you. This is the C# language design repository. It's a meta repository. It doesn't contain any code, but it contains meeting notes, and the Issues tab is largely used as a message board. If you go to the Issues tab, you can also click Milestones, where they can flag certain issues for either inclusion in a specific version. So if you go to like C#9, you'll see a list of all the discussions going into all the features for that version. You can also go on and see what's planned for C#10. You can also see there's a bucket called not likely or unlikely, something along those lines, where it's this language features that they've discussed, but have decided against and may or may not pick up in the future, but at this point consider them largely dead. So if you want to see everything there, because it includes the full discussion with the community members and the language design team, along with their meeting notes, really valuable and pretty accessible too. So just not quite last year, but in 2019, C#8 released just a quick rundown of its features. It has indexes and ranges. We saw enhancements to pattern matching. We'll continue to see that in future versions of C#. Default interface methods, nullable reference types, async streams, and a lot of other stuff. So it was a really, really large release. The biggest thing here I would have to say is nullable reference types, allowing you to better protect against nulls and better expect when nulls can show up through your type system. That's actually expanded, by the way, in C# 9. It's not really a language feature. It's not going to go into much detail on it, but there are more annotations that work with nullable reference types, shipping as part of .NET 5 and available for use in C# 9. So today we're going to talk about C# 9. It was released in November last year, and I'll include this link in the chat room after if you want to go here. I really like Microsoft's article this time for this version of C#. It goes through great detail on all the new features, groups them nicely, talks through really about a lot of their history, about what they're used for, how they came about, and goes into great detail. So if you're interested in what you hear today about C# 9, I highly recommend you go over to there later today or as soon as you can and read through that article as well. Now, lastly, you have to be sure that C# 9 requires .NET 5. Now, there's been a few talks today already about .NET 5, but let me just do a very, very brief intro of what that is. So at the beginning, we had the Microsoft .NET framework, and that was released for Windows and Windows only, and ships with Visual Studio Tools and some versions in Windows itself. This is installed in over 1 billion, maybe even close to 2 billion machines at this point. And it's the largest installation base of .NET by far. Now, recently, it's reached its end of life, and there's an asterisk there, because if you have a product built on .NET Framework, it is still supported. There will still be fixes for security issues and for other things that are critical to keep .NET running safely on your machine. However, they're not going to add any more new features to the language, to the runtime. That's the language may depend upon, and also the library class, the base class libraries, the standard libraries. Those are kind of fixed at this point. There may be a few additions, but largely it's frozen. So it's end of life from a feature perspective, not end of life from a support perspective. Now, there's lots of other versions of .NET that exist out there. One of the next most impactful ones is Mono. It's been the baseline for so many other projects, including Xamarin and Unity. It's really impactful to the community. And then Microsoft also started later on .NET Core. And both Mono and .NET Core are platform agnostic. They don't just support Windows, they support many different platforms. And there's some features of Mono that are fantastic, some features of .NET Core that are fantastic. Together they make a really great, rich feature set for programming in .NET. And now with .NET 5, it's essentially a combination of them. There's a lot more that goes into .NET 5 than that, but super high level, it's a combination of the best parts of Mono, the best parts of .NET Core, and this is the future for .NET development. One single .NET platform that everyone's contributing to for the future. So again, .NET Framework is dead only from a feature perspective, not from a support perspective. But if you want these new features that we're talking about today, you're going to have to move. Some of these are available in .NET Core or .NET 5.0. Now, the compiler is, in your tooling, only going to be active if you're developing against .NET 5.0. But not all the features strictly require .NET 5.0. Some of them do, a lot of them don't. Now, you could, if you really wanted to, target a different version of .NET and still get a lot of the same features. You're going to have to know which features work and which features don't work, which features rely on runtime improvements and which ones don't. And some of them also rely on new advancements, new improvements to the standard class libraries, which you can augment in a way if you want to still go against older versions or .NET Framework. But I really advise against this because .NET's going to continue evolving, C# is going to continue evolving, and if you go down that path now, it doesn't end in a very good place. You're going to eventually get lost in trying to keep everything tracking. Your developers are going to have a bad experience. So if you want the new features in C# 9, now's the time to start moving off of .NET Framework onto .NET 5. And they've done a great job of making the transition as easy as possible. There's great API coverage, so now's a good time to start looking at making that transition. I know this is not the long-term release, so perhaps .NET 6 is what you're going to want to release in production and keep running for a while. That's up to you. But I would start looking at it now. It's probably not going to be an overnight task, and it'll keep your project current and relevant using the latest C# features. Right, so we're going to move on to code. And the code today, I'm going to be using Visual Studio 16.8.4, which is the latest version of Visual Studio as of today. First, let me check in. I don't have a second monitor, so let me just check in to see if we have any questions or comments or anyone's raised their hand. All right, doesn't look like that. So I'm going to go ahead and I'm going to create a new project in Visual Studio. So I'm going to go ahead. I made the fonts a little bigger, so it's easier for us to see. That makes this screen look a little wonky. So I'm going to create a new project, and I'm going to choose just a console app for .NET Core. Now, even though we're going to be developing against .NET 5, unfortunately right now there's no templates available directly for .NET 5. So I'm going to start with .NET Core. I'm going to call this demo and let this project get created. Now, .NET Core projects start you off in .NET Core 3.1, and by default, that's going to give you C# 8. So for now, if you want to develop in C# 9, you're going to do one extra step. You're going to go to your project properties, and your target framework, you're going to go ahead and set that to 5. And now it's going to automatically move you to C# 9. If you go, I think it's under Build. If you go to Build, there is an Advanced tab at the bottom, which brings you up to Language Selection, but it's not available anymore because C# 9 requires .NET 5, C# 8 requires I think .NET Core 3.0, and because it's not very obvious necessarily what version of the runtime you need for what version of C#, we just made it all automatic. You can still override this if you want, just not from the UI. If you double click on your solution or your project, you can see the target framework right here, and you can enter whatever you want. You can also, to get the version of the language, you can go to, I think it's called lang version. And it's going to start with 9. You can bring it down to 8. I don't remember exactly what the valid values are here, but you can look it up and go to whatever version of C# that you'd like. Fantastic. So one of the first new features I want to talk about, and I think you saw this in the last demo too. Okay, my Visual Studio just is not letting me. Oh, there we go, clicking off of there. All right, don't save. There we go. So one of the first new features I want to talk about, it's a small feature, and it's helpful in a very, very specific situation. But this is one of the situations I think will help with. So it's called top-level statements, or also known as simple programs. So, right, this a class in .NET. Sorry, so in order to start a .NET program, right, you have to have a main entry point somewhere. That main entry point has to be a static function which exists within a program, a class, and that class must exist within a namespace. So this is all fine and good, but when you're trying to do a small demo or write a small console application, it may sometimes be a bit cumbersome. I'm already tabbed in like 4 different levels here. So in C# 9, what you can do is have that at the top level. And then I can run this, and then you'll still get hello world. So this is intended for very specific use cases, such as giving a demonstration on language features or writing a very small console application. But it's not magic. And what's actually happening here is it's taking everything I put in this file and shoving it basically into program main. I'm going to use ILSpy that I have installed as a plugin. And we can see exactly what the compiler is generating for this application. I'm going to go into my program here. It's kind of hard to see. I can't make this font really bigger. But on the left-hand side, you can see there's this program class that's generated for me. And it's generated by the compiler. We have program still there. We have main still there. There's no magic. That still has to exist in .NET. But what's different now is that it's taking everything I have and putting it into here. So if I have functions in this top-level statement, they're going to be private local functions here. Everything, without exception, just gets put into program main. Now, because of that, there's not a whole lot of smarts and a whole lot of complexity around this feature. So you can do this, but you can only do it with one file. This is not a scripting language. It's just an easy way to get started if you want to reduce some of the ceremony. And for demo purposes, it's quite nice, so I think I'll leave it that way. So the first new feature that's really significant, I think you just saw it before, but I want to go over it again, is C# records. So let's define a very simple record. I'm going to call it person. I'm going to give it a last name. And that is a full type definition for a person. So with this, I can create an instance, call it me, of new person with my name. And then let's see what happens if I print that out. So here I created this thing called a record, and I create a new instance of one, and I'm printing it out, and let's just see what happens. So very friendly. I get the type of the record, and then I get my first name and my last name. So what's actually happening here behind the scenes is the C# compiler is generating an entire class for me based on my record definition. And it's enforcing some rules about the record. One of the rules, we'll talk about, there's some exceptions to this later, but the big thing about records is they're intended to be immutable. So once I create my new person, I shouldn't be able to change the name. So it's giving me a squiggly here. It won't let me compile because records are designed to be immutable, and it's basically telling me as such down here. All right, so that's quite interesting. So let's take a look at what's actually happening behind the scenes of a class. Let's get this compiling and running again. Let's take a look at what the class is being compiled for the records. I'm going to go to ILSpy once again. ILSpy, by the way, is just a free plugin you can download for Visual Studio. It's also a standalone exe, and it's been around for quite some time. It really is cool to let you see exactly into what your compiled program looks like. It's reading the metadata, it's reading the IL, and showing me the output of the compiler. Now I have C#9 selected out here, so it's going to try to make everything look like C#9 code. But you can select any language you want all the way back to C#1. So if you see here, I still have my program, and I still have in this program my main method, and it looks right exactly what I have here. But of course, the record now, it saw that that's a separate type, and it created a type person for me. All right, so the type person here just looks like that because I have C#9 selected. If I go down to C#8, it's going to not hide all the niceties behind the scenes. So quite a bit was generated from just that one line of code. So we have a class of records are classes with equality contracts with my properties that I set, first name, last name. We have our constructor, and then we have an overridden toString. So when I tried to print the record out to the console, what was happening is it was calling toString and has this custom implementation that is exactly what I wanted. It displays here person and puts everything, all the member names in parentheses, looking very similar to an object initializer. It also overrides equality. So we had not equals and equals operators, hash code, equality helpers. And then there's something here called clone and a constructor that takes in an original object. We'll explore that as well. And a deconstructor. So deconstructors are quite interesting. They were introduced a couple versions back. That allows me to assign the properties of this directly to variables. So I can do var first name and last name, and just set that equal to me and deconstruct me. So because I have the constructor parameters in a certain order, right? There's first name and last name, I can deconstruct them in the same order. And then here I can, instead of writing this, I can write an interpolated string with my first name and my last name. So I run this now, instead of typing out just the record toString, I'm going to type out this name, and that works. Another thing we saw in the compiled code is helpers for equality. So what that means is it's actually implementing value equality on our person. So if I create another separate person, let's call a clone. If I create a clone of me, it's exactly the same properties, but it's a new instance. Let's see what happens if, let's do an equality test. So I do an equality test at the right mark console position. So I'm just going to do it now. I'm going to check if me equals the clone. This is an equality check for overloading equality. And for equality checking, it's going to look at a couple things. It's going to look at all my properties, and it's going to look at the class name. So these are the same class. All the properties are the same. So when I run this, we can see that equality is true. Similar to structures. Now, if I try doing this again, but with reference equals, we can see that they are indeed separate classes. So let's do reference. And instead, let's do reference equals with me and the clone. And I would expect that to fail. They're not the same object. But because we've overwritten equality for free, we got that part of a record, then they are considered the same equality, but not the same reference equality. And there we go. Equality is true. Reference equality is false. Now, there's quite a bit more to records as well. So for example, you can also have functions in methods in records and override things just as you would a normal class. So I could in here have public override string to string. I can replace this with a nice interpolated string of just my first name and last name. And then if let's get some of this gone, if I just print me, this time it'll use my toString, not the one that's auto-generated. Yeah, there it goes. In fact, if we go into the IL, back to see what the compiler outputted, we can go back to the my record person, and you can see toString is just what I wrote. It did not emit a new toString because I already had one. And this works with pretty much any method that you have within the record. Now, you can also do interesting things. You can add additional properties this way too. Public int age, for example. Let's do get and set. And now I have age added. So I can access that with a initializer syntax. And I can print it out. Let's see, so print it out. And I should get age. Oh, I don't get age. I just get my name. So what's going on here is I still have my toString, which is overriding what would normally be created by the records. So if I delete this, I'm curious. So it's not part of my constructor, but it's part of the record itself. So let's see if this works. And indeed it does. So the toString looks at all the properties of your record, not just the ones you create in your constructor. Now, there's some problem here that's going to be a little subtle. Now, a record is supposed to be immutable. So I shouldn't be able to do age equals 21 and write that out. But it lets me. That works. So this is a very important reminder that record is providing framework and help and infrastructure for creating a class. It's not going to be enforcing all the rules. You can definitely shoot yourself in the foot and get yourself into a bad situation. So if you do this, this is possible, but it's kind of breaking the rules of what you expect a record to do. So please don't do this. You can similarly change the access modifiers and get yourself into some weird states, but I really recommend just leaving it as simple as possible. These are intended to be simple data carrying immutable objects. But if you notice here, I can change this, right? So there's a problem here. So I want to be able to define the record to only set it at the beginning, either during my object initializer or in my constructor. And there's something you added to C#9 called Init that does exactly that. Anytime during the object's construction, it can be set, but then after, it won't be. It's read-only. So I get a squiggly, and if I try running this, it doesn't work. Excellent. So if you want to add properties to your record, you have to use init, not set, to still get that same behavior. So if I do want to change my age, what can I do? Well, it's immutable. So changing my age is not really changing my age, but it's making a copy with everything being the same except for my age. And I do that. I can show you can do younger me in this case, and I can do me. I'll use the with keyword, which is specific to records. And then I can change anything I want during the copy. So it's going to create a new instance of person. It's going to copy everything over, but it's going to allow me to override those values. So it's going to copy my first name and last name, but it's going to change my age. And if I do younger me, there you go, age 21. Now the first one is still completely unchanged, right? These are not references, they are values. So if I want to come back here, waiting. I'll do console.writeLine. I can write both out. And you see me is still at age 38, and younger me is now 21. Fantastic. If you want to just make a copy, by the way, you don't have to include anything in the with brackets. This is perfectly valid as well. It will create a copy with all the same values, but it will be a copy then that you can pass forward with a different reference. So if I can do age this way, do I really need to do this constructor? And well, no, you don't. You could write the entire record with properties, as long as you very much keep in mind that the second one must be init to get this read-only behavior. So it's still a record. I don't have the constructor, so I can't write it quite this way. I'll have to just use first name, last age. But the behavior of the record is just the same as it was before. I can set my first name to Tom, whatever have you, and it all works. So in this case, it changed my first name, and the original is unchanged. So if you prefer if you prefer to write your class this way, you can. Just keep in mind, without a constructor, you don't get the deconstructor. So because these are not defining a specific order, the deconstructor is not created. So if I go to the IL again, I can show you this. If we go back to our person, before we had a deconstructor at the very bottom. Order is not guaranteed here, but if we look through, that deconstructor is not here anymore. Now you can always create your own if you want, not a problem. But if you want a deconstructor, you're probably just best going with the more simple syntax of, string name, string last name. Let's go back to this. Now, records do support inheritance, so I could create, let's say, a student, which has a first name, a last name, and let's add in a GPA. And I can inherit from person. Now there's no magic, we're not doing any name matching. There's nothing that magically makes the person understand that first name and last name here positionally match. That's too restricting. So you still have to pass in the first name and last name to the secondary constructor as you would a normal class. And now let's change this. I can create a student. First name, last name, and my GPA. We'll do 3.0. And then if I print me, you'll see student, first name, last name, GPA. Now, this is automatically taking the type of student, but I could also specifically cast it to person. But because it's overwriting the toString, it's still going to print with the full information about the student. If I make a clone, let's do var smarter me. And let's say I want to, or I guess I'll just call it other me. I want to take my me and I want to change, let's say this time we'll use with, and we'll change my last name. Whatever. Now, even though person me is currently cast as person, the with operator doesn't care about that. It's still going to copy the entire record. So I only have access here to change the first name and the last name. I don't see GPA in this list, but it will still copy over the GPA. If I do other, if I print that out, you'll still see that. So the GPA still comes over, but I don't have access to it from talking to it as a person. Now you can have access to so you have inheritance access here, but you have to be careful. The compiler is going to enforce that records inherit from records and classes inherit from classes. Mixing the two opens up just too many weird edge cases and is not really the intended behavior, so it's forbidden. Okay, and that's pretty much classes here. One other thing I want to show you before we move on is there's another thing in C# called targeted type new. So if I do var me equals student, var is going to automatically pick up the type student. But so it's the same as writing this. Now some people don't like var, or it's not always the most appropriate in every case. So in this instance here, I can just, since students on the left-hand side, I could simply do new and omit the type, without the, and that works as well. So because the type's on the left side, now in C#9, you don't have to repeat on the right side. This is also useful if you're passing in a record into or any other object, right, into a class, into a method. That method already knows, the compiler can figure out what you're trying to create. So you just have to include the new keyword if you want. Pretty valuable. Okay, excellent. Let's go back to slides. Was there any questions about records first? I'm checking this correctly. Anything in chat or whatever? Okay, no. So let's continue on. I want to talk to you about other features in C#9. So these are, we're going to go through, there's a lot of other smaller features that I'm going to go through with just slides, to go through a little bit quicker. So the first is going to be new features. This is, Microsoft called this fit and finish in their article, and I really like the name, so I'm going to totally steal that here. And first thing I want to talk about is native size integers. These are all small little features that make programming a little bit nicer. So in C#, there's a system.int pointer, which gives you a native int size, and a uint, which is a native unsigned int. And now in C#9, there are proper types to access those. And along with the proper types come improvements to automatic implicit casting between them and integers and other types that are just make this a little bit easier to work with. We also have covariant returns. So the name's probably a little more daunting than the feature actually is. Let's say we have a pet and a dog, which is a pet. And let's say we have an abstract class called a pet adopter right here. So you can see there's an abstract class which is adopting and returns you a pet that you've adopted. So let's say I want a dog adopter, and I'm going to implement the pet adopter class. Well, I'm a dog adopter, so I'm going to override adopt, but I'm going to return a dog. Now, that should be okay, right? Because a dog inherits from a pet. So this is not really changing any of the signature. You can still cast a dog to a pet, so everything can still work through the pet adapter accessor, pet adopter accessor. And now in C#9, this is called covariant returns. It does castings happen implicitly behind the scenes, and this works exactly as you would expect it. In fact, the targeted new types here, right? We know at this point it's going to pick up that this is a dog, so I don't have to repeat the dog if I just want to find a new dog from the kennel or whatever. There's also targeted type conditionals. So in earlier versions of C#, let's say we have some Boolean condition, and I want to set equal to an integer or null, and I want to store it into a nullable integer. I mean, that sounds like it should make sense. But it didn't work before, and in C#9, now it does. C#9 understands that there's an implicit conversion between 42 and int nullable, and null and int nullable, so it allows it. Now, this only applies for this conditional operator. It hasn't yet been applied to like null coalescing operators, and perhaps it will in the future. It's just not there right now. This can also be useful for working with collections of different types. So there's a list or an array, it doesn't matter, they're both enumerable, so I should be able to set, based on some condition, a value x equal to either the enumerable of list or array, and this now works. The thing you have to keep in mind is this is powered by implicit conversions. So if you don't have implicit conversions, this won't work. And I tried doing this with just using type, a type hierarchy, and I actually couldn't get it to work with a type hierarchy. So I think because I don't have those implicit conversions in there, it's just not going to work. So there's still plenty of room to grow with this feature. If this goes over well, I would expect similar types of improvements in C#10 and beyond that makes your code a little bit nicer to work with. Again, this is not going to be life changing in your program, but it's one last cast you'll have to include. Local function attributes. Now, if you have a local function of another method, before you couldn't give it any attributes. In this case, I'm applying a compiler attribute to tell it, I want this compiled or JITted a little differently. But you can also use this for nullable annotations as well now. So this is allowed in C#9. And you can also use the static keyword. You can always use, so right, let's go back one. You can see here this is actually a static local method, which means it can't capture any state outside of itself. It doesn't create a closure. It's real easy to accidentally create closures, which use a lot more memory. And if you want to be more efficient in some ways, you might want to specifically avoid that, or you might want to avoid it to accidentally to make sure you don't accidentally do something you're not expecting. And accidents do happen, so it's nice safeguards to have. So that now applies to lambdas and anonymous methods in C#9. So I have this method here. I don't want to bring in 10. It's almost like a constant. So I just want to do something plus 10. And it's going to create a closure for me right now and include a reference to int y. I can prevent that from happening by adding static to the beginning of the lambda. Now, this won't compile because it's going to give me a warning that, well, y is not a constant, or, so I can't reference it. So if I make that a constant, now this works. A similar small improvement to lambdas is that if you're creating an implementation and you don't care about a parameter, you can now express that with an underscore, the discard character. So you can discard any parameters you don't care about. And this is really useful maybe in event handlers or times where you just want to return a static or constant value. There's also ForEach extensions. Throughout the C# language, there's many different places where you can use a pattern, where ForEach is not looking for, or in this case, ForEach was looking for, its exact method on your object called getEnumerator. And if it didn't have it, then it won't work. But in other parts of .NET, especially with async, the compiler looks at extension methods, but it never did that for each. It does that now in C#9. So here's an example I've come across a lot in people discussing this feature. If you have an enumerator, you can't iterate over it because it doesn't have a method to give you an enumerator. Like it is an enumerator, it doesn't have a method to give you one. So in this case, I'm writing an extension method. The name of the class doesn't matter, just has to be static. And this is creating extension methods aren't new, but I'm creating one for getEnumerator. And in C#9, what is new is the ForEach syntax is going to pick up on this extension and allow this to work. Please don't abuse this, but in some certain situations, it could be quite nice. Now, there's also a few new features intrinsic to how the compiler expresses your code in IL, intermediate language, how it compiles your code. I'm going to briefly go through these. There's a lot of people using C# now for high performance tasks, such as building low-level web servers or video games. So some of these improvements are to make that a little bit easier. Now, if you use a regular function delegate in C#, it's going to use some IL called call virtual, and invoke the invoke method. And there's a little bit of overhead involved with that. So there's another option in IL called call_i, which you didn't have direct access to from C# before. So now in C#9, if you do a delegate star, that's called a function pointer and expresses itself in IL differently. If you've never encountered this, don't worry about it. Probably most of us won't have to get this detailed in our optimization, but it is a new feature in C#9. There's also another feature called skip locals init. When you create a new method in C#, the first thing it's going to be doing is setting all of the variables to 0. And to give you that baseline expectation. But in some cases, you don't need that to happen, and you don't want the time taken to do so. So in those cases, we are going to, we can say, don't do this and save a little bit of time. Now again, don't just go applying these everywhere. Be sure that you actually have a problem. Be sure that this will actually make it faster. Do your proper, your performance monitoring, performance profiling. Don't just throw these everywhere. But if you need to make something a little bit faster, there's those options too now. And I'm going to talk about code generators at the end. I'm going to show you a demo, but also new to C. It's not really a C#9 feature. It's the compiler with C#9 lets you add code generated on the fly. Now, the code generators can only add to your compiled code. It can't remove anything or alter anything. So because of that, partial methods and ways of augmenting existing code that you have is a lot more important. So this is already existing in the framework, partial methods. What you see here, I have a partial class foo with a bar, and there's no implementation. And then in another class, also called partial class foo, I can provide an implementation. I don't have to provide an implementation. And if I don't, then the compiler just throws away bar and all the calls to it. And that's why bar is not allowed to have any side effects. It can't return anything, can't have any out parameters. It's very restricted, such that the compiler can remove it easily if it needs to. But that gives you some limitations to with code generation. So in C#9, those restrictions are lifted. You can have a non-void return type. You can have out parameters. You can also set the visibility, accessibility from anything other than private to whatever you like. But the new restriction is your generated code must provide an implementation. If not, that's a compile time error. One last thing added to C#9 for code generation support is a module initializer. So you have a way now of defining an entry point, a static method in your application or in your DLL in your module that will run immediately as soon as it's loaded into memory. And this is a great entry spot for code generators to do some work up front. And you might find some use cases for it in other instances as well. Well, so let's go back to code. And there's a few more things I want to show you. I want to show you improvements to patterns. And then I want to show you, we'll take some time to actually show you code generation and talk about that for a bit. So I'm going to bring up a demo of patterns. And there are some improvements to pattern matching in C#9. So here we have a very simple application. We have a menu item, and I have two possible menu items. Pizza, which adds basically a size, a diameter, and then soda, which I don't need any additional information. Just it has different names. That's fine. And in my program here, I've defined a menu. So items on the menu. I have some cheese pizzas of different sizes. I have a mushroom pizza and some sodas. And I have this method called generate menu, which is going to return a string. And I'm going to write that string out. And it looks like this when I run it. We got some pizzas, some cheese pizzas of various sizes, and then my drinks. And I'm using patterns to help me generate that code. So I'm iterating over the items, and then I'm going to use a switch expression introduced in earlier versions of C# to make this look a little bit nicer. So this works in C#8. And for pizzas, I have 3 different sizes. So I have 3 different line items that are, checking for the diameter. So if it's less than or equal to 6, it's small. If it's greater than 6 and less than or equal to 12, it's medium, and greater than 12 is large. And then for sodas, I don't need any more information about them. I'll just call them a drink and send out their name. So, but I still had to include this underscore. So there's a small feature in C#9 where if you're just checking on the type, but don't have anything else you want to do, that underscore is no longer necessary. Small feature, not going to change the world, makes your code just a little bit more readable. What is more significant is range, relational patterns, and also logical patterns. So this is not the easiest to read. It should be, you can probably do a little better. So let's do a little better. Let's do pizza. We still want to switch on our pizza, P. But this time, I want to use p.diameter and perform another switch, a second level, a nested switch expression. Let's try moving everything here to try to reduce some of our code here. So in this block, I know it's a pizza, so I don't have to do that anymore. And I know its diameter, right? That's already selected. I'm switching on that, so I don't need that at all anymore now too. So I can just delete these, and notice things actually working. Oh, this is the pattern, a little confusing with equalities because you also have the lambda operator. But this is an expression that's now valid in C#9. You can do all the regular relationals you'd expect. And here we do. So I don't need diameter, so I already know what I'm working on. But before I was using an and now that this is working with patterns, I don't have that and the double ampersand available to me, but I can have a logical pattern of literally the word and. You also have access to the word or and the word not. So this is the same functionality I had before, but my my cases are a little bit easier to read and understand. There's less cruft there, and it works the same as it did. So of course, it's just a contrived example, and I'm using a switch statement to express this, but anywhere patterns are allowed, you can now use and or not. You can also use these relational ones. So this is really useful in null checks. 1, let's comment this up. Okay, let's just delete this. Of course, my keyboard wants to be extra sensitive when it comes to typing on a call. All right, so let's do string x equals null. I'm going to say if x is null, I'm going to write something out to the console. I'm just going to do console.writeLine null. Perfect. So I'm going to run this. You'd expect it to output null. Perfect. Now, this is actually using the equality compares, and this can be overloaded. So if you don't want to do it, if you just want to compare references, you can also just use, in C# the is pattern. X is null, and this is going to be equality reference, and in some cases, just a little bit more efficient. So if we run this, we get the same result. Great, but what happens if I want to do when it's not null? So let's say hi, and if I want to say when it's not null. Well, before, in C#8, if you want to do this, you'd have to apply a negation operator to the entirety of the pattern, the pattern I wrote here, which is less than ideal, right? This is already kind of subtle, and this doesn't look very nice. So here we can use that not operator in our pattern and make it very obvious, very nice to read, x is not null. And then this works as you would expect. So those are the improvements to pattern matching in C#9. We have a few minutes left, and I like to spend that time to show you code generators. Now again, this is not strictly a feature of C#9 specifically, but it is available with the new compiler. So I'll check to see. Okay, I don't have a second monitor, so I'll keep wanting to check in on these. Excellent. So I'm going to bring up our next example for code generation. So I have a very simple program here. Just, use a very simple program, and I'm using hello world generated, and I'm calling hello world say hello. So this is a very straightforward example that Microsoft's been providing as examples for using code generation. And this is the main entry point in my CodeGen project. Sorry. There's a second project here with my generator, and this has a source generator in it with the generator attribute. So this is actually going to be using the Roslyn API to allow me to generate code on the fly. Now, this is really, really important to add to the C# because other languages have this in some degree, and C# tries to fake it in some degree, right? There's lots of ways in C# to emit code on the fly. A lot of it's using reflection, and a lot of it's not very performant. So there's always that startup cost. XML serializers does a lot of craziness to get around this. There's as well, JSON serializers might have a lot of help here. So there's a lot of ways that C# already, the library's already creating source code for you. It'd be nicer if there was a better way of doing it. And that's what source code generators are for. Now, there was a lot of discussion whether records would be a source code generator or not, and they ended up deciding that they should not be because there's enough unique stuff that the language has to do if it's a record that we can't just abstract the whole thing away. But the concepts were being developed in parallel for quite a while, and they're released together. So to be clear, records is not a source generator, but it was thought about that for a while, so these are released at about the same time. So there's two methods. There's execute and initialize. I don't have any initialize here, but initialize allows you to write some more complicated code to figure out when and when you should not generate. In execute here, we're creating a very simple program. It's just going to be literally text. We're going to create this new hello world generated namespace with hello world and say hello. And this is just provided from Microsoft. They have this in the docs, and it's an example that's showing you, it's going through the syntax. So basically, the syntax trees represent your code. So it's going through all the code and just writing some information out. Pretty cool. So if I run this, it's going to say hello from generate code. It's going to show me everything that I've created. So it's going to be showing me the files that I have in my program. So these are completely separate from each other. The only thing I had to do is add a reference to this project generator from CodeGen, and then it works. Now, some things you have to understand here. There's some restrictions. The code generator must target .NET Standard 2 for it to work correctly because it's being run by the compiler. The compiler can run on several different versions of .NET. So .NET Standard is currently required as the target for code generators. And you must reference the Microsoft Code Analysis common NuGet package. But as long as those are in place, you can create your generator. And then I referenced it in my other project as a project reference. You can also include it as a DLL reference. With the project reference, I have to declare that it is a type analyzer. That did not happen automatically for you. And the reference output telling me is false. I don't want to generate this. This is just being used for the compiler. I don't want to output this into my distribution. And so all I'm doing here is hello world, say hello. It's an entirely separate class, but this works because of the code generator. Now, if the code generator has an error, let's say here, let's say I purposely exclude this semicolon, and I try rebuilding my main program, it's going to give me an error. So I'm trying to build CodeGen and said rebuild all failed. And if I look at my output, it's going to tell me that it's showing me that it generated hello world generator.cs. It gets that name from the generator at the very bottom when I'm adding the source code to the project. Context.add source code. I give it whatever name I want. It doesn't really matter. And then the source code. But it's referencing this name in the compiled output of CodeGen and letting me know there's a problem. It doesn't see them as separate projects. It's adding the code and then compiling my entire application. So be sure you test these quite thoroughly before you put them out there. And that'll fix it. So let's just compile this again, rebuild it. And I just want to show you how this looks from an IL perspective. So if I look at this in ILSpy, look at what was generated by the compiler. You can see there is hello world generated as a separate namespace, this hello world class. And because it's generated code from the compiler's perspective, everything that's in my project, all the files, my path names, these are all just constant values because it was generated on the fly during compilation by the compiler. So I don't think this is powerful enough to necessarily solve a lot of your aspect-oriented programming wishes, but it could get you there, and it could get you pretty close to there. And there's a lot more things you can do with pre-generating helpers on the fly, things like database mappers or XML serializers. Anything like that is prime candidates for speed improvements and startup improvements using code generators. And just keep in mind that code generators are additive only. You can't use them to rewrite your code because the side effects of that are just a little bit too daunting. All right, we're actually just about at time, and that's everything I wanted to show you today about C#9. Did anyone have any questions or anything you want to go back to and look at?
Yeah, you have a quick comment on code generators. It kind of reminds me of type providers in F# where you can use this to create your own type provider. Wonder if that was the intent.
So I can't speak to that too much because I'm not that familiar with F# personally. But it definitely is the intent to provide this functionality that other languages have. So I don't know specifically about F#, but other languages like Java, Java has this similar functionality through something called like Lombok extensions are a very popular implementation on the Java side. And a lot of the people that designed the Java language are actually the same people that developed the C# language. So they were probably like some ideas and did them in a C#y way. I don't know specifically about F#'s situation though, so I can't directly answer that question. I'm sorry.
Thank you.